3D printing is literally building our future. Everything from custom medical implants to absolutely critical parts for spacecraft. But here's the thing, that same incredible power, it's got a dark side. It gives counterfeiters the ability to create perfect, undetectable fakes.
So that brings us to the big question, right? When a fake part looks, feels, and even weighs exactly the same as a real one, how can you possibly tell the difference? Especially when that part is supposed to go into an airplane or maybe a life-saving medical device. Let's get into it.
So, let's talk about additive manufacturing, or AM for short. It's a total revolution, but you know how it goes. For every innovator, there's always someone looking to make a cheap copy. This amazing new way of making things has also become a brand new playground for intellectual property theft. And our old security methods? They just don't stand a chance.
I mean, think about it. How do we usually protect stuff? We stick things on them. Stickers with serial numbers, fancy holographic labels, RFID tags, even those invisible UV markings. But every single one of those is just on the surface. A determined counterfeiter can peel them, scratch them, copy them, or just disable them. For a super valuable 3D printed part, it's basically like putting a screen door on a bank vault. It's just not going to work. And look, the researchers who came up with this new idea, they don't mince words. They say that these old methods are highly subjected to removal reapplication attacks and that this can lead to severe losses. This isn't just some theoretical what if, it's a huge real-world threat.
All right, so if slapping a label on the part is a total non-starter, what's plan B? Well, this is where things get really, really clever. What if, instead of putting the security tag on the product, you put it inside the product?
And here, you can see exactly how it works. It all begins in the digital world, inside the CAD file. The barcode isn't just an image pasted on top. It's actually designed as a series of tiny voids within the part structure. Then, as the 3D printer builds the object layer by layer, it creates that barcode on the inside. It's literally baked right into the part's DNA.
Okay, I know what you're thinking. Wait a minute. If you're putting a bunch of tiny holes inside a super important part, isn't that, bad? Doesn't that make it weaker? It's a great question, and it's one the researchers were dead set on answering with cold, hard data.
Well, here's your answer. They took parts with the barcode inside and parts without it, and basically tried to pull them apart. And just look at this graph. See those two lines? They're practically on top of each other. The red line, that's the part with the code, performs almost identically to the blue line, which is the standard part.
So, what's the actual damage? It's minuscule. Seriously, we are talking about a tiny, tiny reduction in strength, about 0.5%. That is an incredibly small price to pay for a security feature that's pretty much foolproof.
And if you look at the hard numbers, they tell the exact same story. Whether you're talking ultimate stress or modulus, the values are nearly identical. The takeaway here is crystal clear. You can hide these secret codes inside without really affecting the part's strength or its ability to do its job.
Okay, but hold on. What about the ultimate heist? What if a counterfeiter doesn't just copy the final product, but they manage to steal the actual digital design file? I mean, if they have the blueprint, they can just print their own perfect copy, barcode and all, right? Well, not so fast. This is where another brilliant layer of security comes in. And it's a concept called obfuscation. Basically, it's a digital booby trap, a secret little trick that's hidden not in the physical part, but deep inside the code of the design file itself. So let me break down how this little bit of genius works. Normally, you design the barcode by just cutting out empty spaces from the model. Pretty straightforward. But the obfuscated design is way sneakier. It uses a series of surfaces with zero thickness inside the model. Now, most 3D printing software will just ignore those, unless the part is positioned in one very specific, secret orientation.
And this right here is the magic trick. Look at the top picture. That's what happens when the thief prints the file in the wrong orientation. The printer's software just sees a solid block and prints a solid block, no barcode. But then, look at the bottom. With the secret key, the correct orientation, bam! The software suddenly sees those hidden surfaces and creates the toolpath to print the barcode perfectly.
So what this means is the stolen file is basically worthless without that secret handshake. A counterfeiter can have the file, but the part they print, it's a blank, a dud. It's going to fail authentication every single time because that secret code just won't be there.
Okay, so this is amazing, right? We have a secret code embedded inside the part that needs a secret digital key to even exist.
That is fantastic security. But that brings us to the last piece of the puzzle. If this thing is totally invisible, how in the world do you check for it?
So here it is, the finished part. It just looks like a solid piece of plastic, right? The very thing that proves it's real, the thing that makes it authentic, is completely and totally hidden from view.
Until you give it some X-ray vision with a micro-CT scanner. And boom, just like that, the invisible becomes visible. The hidden barcode pops right into view in perfect detail, all ready to be scanned and verified.
So the whole verification process is super robust and actually pretty straightforward. First, you scan the part without hurting it at all. Then you use that scan data to build a new 3D model. And finally, you just analyze that model to read the code. It's a clean, reliable, 3-step check to know for sure that a part is the real deal.
So, yeah, this is some incredibly clever tech. It's really cool. But let's bring it all home. Why does any of this really matter?
Well, it matters in places where you absolutely cannot afford a fake. Think about aerospace, where you need to know with 100% certainty that every single component on a plane or a rocket is genuine. Or in medicine, where a counterfeit implant isn't just a fake, it's a direct threat to a patient's life. And of course, for designers and engineers everywhere, it's a powerful new tool to protect their hard work from the second it's created.
At the end of the day, what we're looking at here is a complete game changer for product security. It's a feature that isn't just tacked on top of a product, it's woven into the very fabric of the thing itself.
And that really just leaves us with one final, mind-bending question. Now that we can embed complex, secret data directly into the structure of physical objects, what else are we going to hide in there? What comes next?